In this video, we are going to introduce the periodic table. Last time, we talked about what elements were. Elements are organized in the periodic table. I tend to think of elements as the building blocks of everything in chemistry. And if the elements that appear in the periodic table with their own symbols make up the letters of an alphabet, then this is my alphabet right here, contained in the periodic table. We will learn in subsequent chapters how to use the symbols, these letters, to write words, which will be compound formulas, and then combine those into sentences, which would be chemical reactions. So let's take a look at the periodic table. Each element in the periodic table is ordered. So it's placed here in a certain order, increasing, right, with hydrogen starting as element number 1 and increasing in order as I go across the rows of the periodic table. The number that appears in this table here appears above the element in its box. It's called the atomic number, or Z. This corresponds to the number of protons that are contained in that element. This is very important in chemistry because the protons are sort of the fingerprints of that element. If we change the number of protons, we also change the element, the identity of the element. As you can see here, the first element is hydrogen, and it's element number 1, so it has 1 proton. If I move to the next element, which is helium, helium has a number 2 above it, which means it has 2 protons and a Z number of 2. Lithium is element number 3, so it has a Z number of 3, which corresponds to 3 protons, and so on and so forth. All of the known elements in nature are arranged by the atomic number in this configuration here. What we also see in these boxes, besides the Z number or the number of protons, is the chemical symbol for each element. As you can see, for hydrogen, that is H. For helium, that is He. So every element in the periodic table has a shortcut, a symbol that we associate with each one. This is just to help us write in shorthand. We don't have to write full names of each of these elements. Now, some of these might look familiar to you, some of these might look different. For example, Mg for magnesium, that makes sense, but sodium is Na. How is that? Well, some of these elements were discovered way before English became the main language that is spoken in all over the world, right? The common language that is used in any scientific setting or conference and whatnot. And so they were named before that, and they typically were named by using Greek or Latin names. And in Latin, the name for sodium is natrium, and so you can see that Na is the correct shortcut for that name. Let's look at a sample problem here. If I have the name of the element, let's figure out what the chemical symbol is and the atomic number. And then if I'm given the chemical symbol, figure out the element name and the atomic number. Or lastly, if I have the atomic number given, can I figure out the name of the element and the chemical symbol? So let's take a look at the first element, which is calcium. For any of these problems, we will go straight to the periodic table. So here's the periodic table. Let's take a look and find where calcium is. Here it is, calcium. The name is written below, and here's the two-letter abbreviation for that is CA, and the number above it is 20, which is the Z number, and it tells me the number of protons. So if I go back to my table here, calcium corresponds to the chemical name or symbol Ca with an atomic number or Z number of 20. Let's figure out what Cu is. We go back to our trusty periodic table and we look through the rows here until we find Cu, the symbol for copper. The name of this element is copper, and then we look above it to find that it's element number 29 in the periodic table, which means that it's got a Z number of 29 or 29 protons. We can then go back to the table and fill in copper and the number 29 for atomic number. And lastly, we'll look at atomic number 13. Let's go back to the periodic table, and we can start by looking at the numbers above each element and then figure out where 13 is. That is element number 13. It has a Z number of 13. It's got 13 protons, and it's aluminum. It's got a symbol of Al, and the name is aluminum. And we go back here and we fill out the rest of the table. Now here is a sample problem for you to try. Identify the atomic number and the identity of each atom shown, of course using the periodic table. Protons are blue, neutrons are red, and electrons are green. So going from the previous slides that we talked about what the Z number corresponds to, we said Z number is the number of protons, and once we know that, we know the identity of the element, and we also know the symbol and the name, the long name for each element. So in these three examples, you will count what the protons are and then figure out what the Z number is, atomic number, and element number, and element symbol and element name. Okay, moving on. Let's talk about the organization of the periodic table. The periodic table consists of 118 elements that are arranged in order of increasing Z number or number of protons, as we mentioned earlier. Now, if we look at the periodic table, we notice that it is divided into rows and columns. The rows, horizontal rows, are called periods, and the vertical columns are called groups. These become very important for us, and we will refer to these in the subsequent chapters. But know that the rows are periods and the columns are called groups. The important thing about groups is that they're organized, so the elements that form in a group, fall in within a group, they have similar chemical properties. And this is important to us because we can actually predict the behavior of these elements just by knowing where they fall in the periodic table. Now, some of these groups have specific names that they refer to the elements that they contain, or they just are common names. You can see that the groups are also named or numbered from 1 to 18. Some tables have 1 through 18. Some tables skip these middle 10 groups right here and go from 1, 2, 3, 4, 5, 6, 7, 8. And some just count them all. But let's look at some of the common names of each of these groups. Not every group has a common name, but group number 1 These elements are called the alkali metals. Group number 2, these elements are called the alkaline earth metals. Group 16 are called the chalcogens. Group 17 are called the halogens, and group 18 are called the noble gases. Each member of this group is placed there because they share common characteristics with other members of the group. They behave very similarly in their chemical behavior. If we think of the alkali metals, group 1, they are very extremely reactive with water, and they're reactive with air, very reactive with air as well. So they need to be kept, to be able to be kept in pure form, they need to be kept in oil, not water and not air, because they react with water, they react violently. And as you go down the group, the reactivity becomes larger and larger. So these are some of the characteristics that chemically that the elements have, and that's partly why they're grouped together. And we will talk more about these as time goes on and as we build on our knowledge. Here's a sample problem. Identify each of the following elements as an alkali metal, alkaline, a chalcogen, a halogen, or a noble gas. So here's these elements. Find them in the periodic table and label them as an alkali metal, alkaline metal, chalcogen, halogen, or noble gas. Okay, the last piece that we're going to talk about in this series is the organization or the division of the periodic table into metals, nonmetals, and metalloids. Most of the periodic table, if you see here in this pale green, is made of what are called metals. In the blue, the light blue, including hydrogen, even though hydrogen is written to the left, it really belongs to the top right-hand side of the periodic table. These are called nonmetals. And then, as you can see in this kind of orangey yellow and the stair step, we call this a stair step. You can see this division here. Several of these elements have characteristics that are between a metal and a nonmetal. And so they're called metalloids. Metals are very good conductors. They are shiny, they have a luster, most of them are gray. Pretty much everybody, all of them except one are solids at room temperature. They are malleable, they are ductile, so they have they conduct heat and electricity very well. So these are some of the characteristics of the metals. The nonmetals, on the other hand, have almost opposite characteristics. They don't conduct very well, neither heat nor electricity, so they can act as insulators. Most of them are gases, in fact, except for one that is a liquid. So they have just different characteristics, and they are grouped together. These metalloids, those few that belong to the metalloids, have characteristics that fall in between these two. So they're not as ductile or malleable as the metals, but they're not as brittle as the nonmetals, and they are somewhere in between. And lastly, we will look at a sample problem. Once again, each of the following elements that are listed here, find them in the periodic table, and then identify them as a metal, or nonmetal, or a metalloid. And at the end of this, we will then continue with the next topic in a different video.